Okay, so looking at this question, in the past what we've found is areas of triangles, and it's been okay for areas of triangles when we've known the height and the base, and we've used that formula, half base times height. Okay, but what we found often with our triangles is we didn't always know the height. Okay, there are times where we had a triangle which looked like that, may not have been a right angled triangle, and we knew the side lengths. And we couldn't use our half base times height because although we might have known the base or the base there, we could flip it over, but we had problems at times, and we don't always know that information. Okay? What Heron's formula does is it's just like we did before with the snail trail that we just did. They created a formula that works every single time. Okay? And so in Heron's formula, what they talk about is S is the side length. Okay, so S is being the side length, and A, B, and C are all the other side lengths there. S they've calculated, if you use all the side lengths and divide it by 2, by adding them together, you find out what S is. Okay, so the process for Heron's formula is to do this first, and then implement everywhere an S appears into what that answer is. Alright, so with this, we've got 6, 7 and 8. S therefore is 6 plus 7 plus 8 divided by 2, and that'll give us S. Alright, doesn't matter what S is, it's just S. We're trying to find S. Alright, when we add 6 to 7 to 8, we get...
What, 6 to 7
8, 6, 14, 21. Divided by 2. S there equals 10.5. Okay. And so in here what they're saying is 10.5 multiplied by the starter brackets 10.5 take away A, end of brackets, multiplied, remember in there, 10.5 take away B, multiplied by 10.5 take away C. And that will give you your area of the triangle with side lengths of ABC. And you have to square root that answer yet. Alright, so I'll slowly just reinforce. You're doing your S and doing all of this and then square rooting it. Okay. The information that this is A, B and C is here. So the information is in your question. So ideally, if you had your time again and you read this very carefully, you would have said, because I feel like you particularly, you're not alone, but you see something new and you panic a little bit rather than to read everything really carefully. Okay? This is telling you that it's A, B and C, A, B, C. So ideally in time you go, okay, well, I know what A, B, C is, and I know what A, B, C is. If I was to do that, I'd find S. Okay, so all the information is there, whether you've seen it or not before. So it's just a matter of process-wise going slowly through all the information and rereading it. All right. Okay, just for those that are into 1F2 that may not have been through it yet, I'll just go through that. You'll see just slightly above, there are some examples to work from. Okay. And all that necessarily does is have you think through here that let's do that top line, A multiplied by B, leaves you with AB, and the bottom line, B multiplied by 2, therefore your bottom line is 2B. Okay, so actually thinking of that as a sum and thinking of that as a sum. All right, so if we were to do that, we end up with AB over 2B. All right. Remember that this is. Can you say? Sorry, you're looking at me. Yeah. A multiplied by B, and 2 multiplied by B. And the moment you see them, you should see, as of yesterday, that they can be simplified. Okay? And that simply leaves you with a over 2, which is what they have there. If we were to go to some of our questions, below, again I would suggest that you look at them as 1 times x, which is, we should know now it's x on its own. And the bottom line, what's the bottom line there, Jeremy? That's all right. Jess? What's the bottom line calculate to? 4. That's just simply 2 times 2, which is 4. Could we simplify that any more is the question you should be asking yourself before you move on to the next question. And the answer, of course, is we can't simplify that anymore. If maybe we were to look at, we'll look at 2a and then 2b. Okay, so we're looking at 2a here. The first thing to do, Sean, would be in 2a, just looking at 2a. Oh, you were staring, that's all. Garrett? Okay, have you been listening along the way?
No.
Oh, okay, sorry. Who's listening along the way? Ash and Harry? And Taylor? Yep. Ash? You could cancel out the A, that'd be another way of doing it, yeah. You could go ahead and do it that way, that's another way of doing it. Cancel them out straight away. 1 times 2 is 2. 4 times 1 is 4. That simplifies to 1/2. You could do it that way. Can you see, Harry, there's another way of doing it? Oh, it's just to get rid of something there for a minute. Not really. Remember what I said before, that we did 1 times x? Could we not do that? Yeah, and what would that leave us with? 2a. Good stuff, Harry. 2a. What's on the bottom line, Harry? Which is good. 4a. Remember now we've got this. And they cancel each other out. Yeah. That leaves us with 2 times 1 over 4 times 1, which leaves us with 1/2. Same answer. Yeah? Like I've always said, there's more than one way of doing a maths problem. If we delete all of that and go with B, the only thing I wanted to talk to you about with B is, what does the whole number of 6 look like as a fraction? What does the whole number of 6, Garrett, look like as a fraction?
6 over 1.
6 over 1. So the first thing for you to do would be this. Okay, Harry? Put that whole number over 1 straight away. Okay? Then what you could do is what Ash said before. You could try and simplify these. You could do that. All right? Or whichever way suits you. You're doing it that way, maybe. Yeah? Harry, it might suit you better to go that way than that way and then process it from there. Okay? So it's up to you how you do it. Taylor, have you decided which way you're going to do it? Not really? So probably the easier way, I think, is x times 6 is 6x. 2 times 1 is 2. And then you look at that and you say, well, 2's going to 2 once. 2's going to 6 3 times. That leaves us with 3x over 1. Anything over 1 is a whole. So we end up with the answer of 3x. Okay? Did you want me to go through any others from there that might, or just get a start? Yeah? Okay, all right, Harry. Taylor, Ash? Do you want me to go through any? No? Sean, coming to you. Yeah, sorry. Yep. Have you started by thinking about anything there? Okay. What was the process you went through with this one, maybe? You split it up, absolutely. Very good. All right. So hopefully you split it up into that part of the question and that part of the question, remembering that the sign belongs to that which comes after it. Okay. So when we're looking at 9a, how would you split up 9a?
9 times x squared. Yeah, minus
minus 2x times 4x. Good. Okay, so from there, if I just said to you, Sean, what's this? Hopefully you'll be able to go 9x squared. All right. If I was to say, what's this?
6x.
Okay. So yep. So stop there.
Oh, hang on, no, it's not. It's 8x.
Okay. So we'll start with the sign. Negative times a positive
Oh, yeah.
is a
Negative.
yes. Shows a bit of a guess, but it should be in your glossary. 2 times 4.
8.
Good. X times x.
X squared.
Good. Excellent. Well done. So what you've got is 9x. Take 9x squared, I should have put, sorry. Take 8x squared. And is that as simple as it can get? What could you do?
X squared.
Good. 9 take 8 is 1. We don't put the 1, so we just put x squared. Good. All right?
Cool.
So keep following the same process. Even though the questions get harder,
Yeah.
don't chuck out your process. Just try and apply